Welcome to Rubber Duck Engineering. This week, we will keep doing waveform collapse. So we have these circuits that are all random and yucky, and they're going to connect and make beautiful circuits.
Happy Thursday, Dr. Barth.
Hey, Eric, how's it going?
Good. Sorry, I had a little technical snafu there. It was we use this like StreamYard thing, so we can go live to the whole internet and all 7 broadcasting sites. Actually, only 3. But this was the first time ever that I clicked the live button and it said, "Oops, sorry, 2 of the 3 things worked, but one of them didn't." So a few of you got an extra 10 seconds of us.
It said it was going, and you didn't do the intro, so I figured I should do the intro.
Oh, sorry, I was fighting to get YouTube to go live because the others had gone live. Anyways, as he said, welcome back. We got to like drawing tiles in random places and like loading up the tiles and stuff. And I think we were pretty close.
Did everything except the algorithm. We got the inputs and the outputs. But
yeah,
we didn't actually make the tiles match, which was sort of the whole point.
Yeah, we needed to have done more in the Easy Bake Oven last week. But I think we're gonna get through it all tonight. I believe we got this. So, any other thoughts before we get into the code machine?
No, I think we should dive into it and sort of refresh ourselves about where we are. These circuits do not line up.
No, but this is our random generation, and I suspect if I...
So close, yes. So close, yet so far.
That was, I refreshed it. So, but yeah, I think we're to algorithm time. If we go back to look and see what we have, looks like we have a single file. Go us. Why is it not showing it?
Oh, your console is huge.
I've got embiggened. Okay.
Right, so we were just at the point where there was this XML file that was telling us for every tile what tile is it allowed to be next to.
Mm-hmm.
And we were just at the point of trying to interpret what this XML file meant. We managed to parse it, and we managed to get the data, but we were trying to figure out what do these neighbor elements mean in this XML file.
Oh, yes, I remember this.
Do you want to pull up the XML file so folks can see what we're trying to interpret here?
Give me 1 second to see if I can find it.
This is all based on this GitHub repository that we're working from that has both the tile set, a bunch of different tile sets for different things, a bunch of XML files that describe each of the tile sets, and then an implementation of the algorithm in C#.
Okay, I think we have circuit.xml.
Yeah.
This is the GitHub.
It's a little small. Can you embiggen it so people can read it more easily? Perfect. Yeah, so we parsed the first part. That's how we figured out all the files to read in. The symmetry...
They have weights.
Oh.
We were figuring out symmetry, I think.
Mm-hmm. Yeah, so I think symmetry means it has the symmetry of that letter. So we can figure it out just from the symmetries of that letter.
Huh.
So that one can be flipped along the perpendicular to that, right? Like it can be flipped along a line from the bottom left to the top right.
And this one is top left to bottom right. And this one's left to right.
And top to bottom.
And top to bottom. And this one's just left to right.
Mm-hmm.
Okay.
And then I wasn't quite sure about these, what these neighbors mean.
Do you mean flipped or rotated?
Either way.
Okay.
I would assume flipped, but we could figure that out.
Mm-hmm.
So I wasn't trying to read this. So like the first neighbor says, on the left you can have a bridge, on the right you can have a bridge. Can we? Yeah. But I wasn't sure what does this next one mean where it says bridge 1?
Left is bridge 1, right is bridge 1. I have no idea. Well, we can go back to the README.
Oh, is there a README that explains the XML file? That would be too easy. Instead of just
it would be too easy.
Reverse engineer it by looking at the tiles and guessing.
No, that's okay. We can cheat. This is a family show.
There's some story about when I was a kid where I was doing something with computers, And some relation asked me, like, did you figure this out yourself? And I said, no, I read a book. So we're reading the book.
This it's going to tell us here. Tile map generation. Okay, list of all the possible pairs. Can be quite long. So I know a symmetry system.
Mm-hmm.
Okay. Same symmetry type. Is there assigned letters?
It's enough to enumerate pairs of adjacent tiles only up to symmetry. Okay. That makes sense.
Okay.
That's the
You're not going to
circuit.
tell us what it means?
Also note that the circuit, summer, and room tiles are non-WANG, whatever WANG is. That is, their adjacency data cannot be induced from edge labels. For example, in circuit, 2 corners cannot be adjacent. Yes, they can be connected with a connection tile. Well, maybe we picked one of the harder tile sets to work with. So I feel like this is not actually explaining what the bridge 1 notation means.
No, but I think let's search for Wang here.
That's the only notion of WANG.
Okay.
You just should know what a WANG tile set is, apparently.
These are samples. I just is there...
You want to try to reason it out from the examples?
Well,
is that
I'm just wondering if they have. It talked about circuit being special or something.
Oh, do you want to try an easier one?
Well, I was just seeing if they have some code that does circuit.
I see.
Right, so then we could just see what they're doing. Okay, it's only mentioned in this.
Okay. I think we should try to reason it out. So let's try to figure out what. So what is the picture for a bridge? A bridge. Okay, it's a bridge is a thing that has I symmetry. It actually looks like a H.
Oh, I see. We're going back to the tile sets to circuit. Oh, I see. Okay. I wonder if bridge 1, if this symmetry generates an array, and this is indexing into the array.
That would make sense. I'm just looking. There's only one. There's bridge and there's bridge 1, and there's nothing. There's no bridge 2 listed.
Well, bridge has 4 ways that it can be.
But most of them are the same, right? If you're imagining.
Yeah. So you could imagine. You can imagine that it's just covering the 2. Bridge 1 could just be 90 degrees.
I see. Okay. And then we have T. So T goes up to. I see T3. In the XML file. So what is the T?
And T has different symmetry, right? It only has 2 modes of symmetry.
I see. T has T symmetry,
but
unsurprisingly.
But isn't that only 2?
Right. You can only flip it like this. You can only flip it along.
But maybe there are different edges that. So I could imagine that this is bridge in normal orientation. This is 90 degrees.
And those are the only 2 bridge orientations that exist.
And so this is then 180 degrees, and this is 270. That's mine.
Okay, so we have to know the order in which they generate the symmetries in order to figure out how to recognize the numbers. So bias goes up to 2. So what is bias?
So I treat these, if these are just rotations, right? This is just a bit mask on the rotations.
Okay. Do you want to start there? Why don't we start there? Why don't we just generate the symmetries for each of the tiles and just try to draw them and make sure that we've succeeded in doing that correctly.
Well, another thing we could do is we could do all the ones that don't have numbers.
I see. Those are the only allowed.
It's not going to get you very many. Anyways, I'm interested in just like kind of soldiering on.
Okay.
I feel like we have kind of enough to do. I really wish that they had like more examples of this running. Like, did they not? Like, how do they ever load these things? This thing? For each size, width, height, periodic, heuristic, scan line. Oh, that's in a different. Okay. Is overlapping. Screenshots. This is not useful. Tile sets, here we go. Subsets, subset, name, tile name. Like, there's part of me that wonders, oh, here we go. Okay. If sim is L, cardinality is 4,
Okay.
A is equal to to a function, a lambda, right? I to I plus 1 divided by 4.
Okay.
And
B is equal to, if it's even or odd, it either goes up or down. And what are A and B used for?
I don't know. Otherwise, cardinality is 1, and A and B are just I equals I.
Okay, so it makes a map of the size of cardinality. Okay, and then it iterates through each of the things and fills in the map.
And A must be like rotate to the right, and B is to rotate to the left.
Mm-hmm. Yeah, so I think we should try to do the equivalent of what this is doing in our project, which is basically generate the symmetric tiles.
Okay. And then if unique, I don't know what that means. I don't know where that came from. Load bitmap. Otherwise.
Oh, wait, this is interesting. Keep going. For t up to the cardinality, if t is less than 3, rotate. Otherwise, for t greater than 4, reflect.
Oh.
So maybe the first 4 are the rotations, 1, 2, 3, 4, and the next ones are the reflections.
I really feel like, and now we should spend the rest of the episode, kids, talking about magic numbers and why they're bad in programs.
Yeah, this is, I don't know, we sort of picked this repository because it looked promising. It had a nice looking README, but the data structure, the data formats are not that great.
Well, it's fine. It's just written, it's written outcome based rather than like, this is not, someone's not writing a library here, or this part is not a library, or someone's not writing this as like a platform to be read 1,000 times.
Mm-hmm.
But the reality is it appears to have become a library. Okay. So rotate and reflect. We have to figure out some magic there. And wait list for cardinality. Add.
The shapes thing, yeah, that seems to be what's going on. Like the L is sort of an L-shaped, looks L-shaped, but they connect in principle on all sides, right? Because there's going to be a tile that's like just a pure green tile with no electronics on it, and so that'll connect up to one side. That's what the like left and right neighbor thing is saying. So they in principle they sort of connect on all 4 sides. Circuit is sort of a special case because you can sort of see the trace lines going through the circuit. But we could do like, there's another one in there for like a town or whatever, where there's like a river and a road or like a building.
All right, so for each neighbor, we look up the left and the right. We split on
space,
and we get this split string. Okay. if the subset does not contain the base name or subset does not contain right name, then we ignore this. Fine.
Int parse. Yeah.
Otherwise, yeah, this is just pulling out the int, right?
It's just the index, yeah.
So the L, the action, first occurrence of the name.
Okay.
I don't know what this is doing, but sure. And either it's a bare name, then we give 0, or we parse. Okay.
Mm-hmm.
I still don't know what this is doing, but sure. And then D, whatever the hell D is the action of L that we just defined earlier in the same line.
I guess. Seems like it must be legit C#. Can you tell me?
What L does this reference? Does this reference this L that we haven't even finished executing the definition of?
This is why I never use the comma operator in any language. It's just massively confusing.
Or is there an L up above?
No, I think it's that one. I don't know if that's legal in C.
Woo! I worry this. I'm turning this into a programming critique show, but okay. Dense propagator 0. No idea what that is. Right and left. Oh, okay. So this is maybe like the.
Yeah.
Okay. And then dense propagator 0, action right 6. Okay. I think we're gonna need to put down we're gonna put down this and just figure it out. Wow.
Okay.
Okay. Great ideas. Not the.
You thought we would just get Phoebe boom done in one episode.
Boom and done tonight.
You did not anticipate the magic number 6 appearing somewhere in the implementation.
Oh man.
But it's I'm sure 6 means something, and so like this is a common feedback I give in people in code reviews. They put numbers like 6 somewhere and be like, okay, what is this? They're like, oh, I'll comment it. It's like, how about you like compute it from whatever it's supposed to be, and then by computing it, we'll know what it means.
Yeah, or the other thing is that if it is truly a constant, name the constant, because it does two things for you. One is that it helps the reader, and the other is it allows you to ever change the constant, because otherwise, good luck finding all the correct instances of 6 in your program to change without changing all the wrong instances of 6.
It's 8. It's like, why is it 8? Because there are 8 bits in a byte. Great. Number of bits per byte.
Yeah.
8. We can all agree that that's true.
Okay. I don't need to hate on this amazing piece of software. And I mean that, like, it's very cool output. I just wish I could better read the code. Okay, so let's. What things can we do?
I think we should generate this.
Go ahead.
No, go for it.
I was going to say, I think we can try implementing a subset of the things we understand, which again is just use the tiles, the neighbor rules that don't have a 1 in them, and try and implement maybe the most restrictive subset of valid reflections or something.
Okay. So I think earlier than that, I think what we should try to do is we should try to, for all the tiles we have, we should try to generate all of their different orientations.
Sure. One thing that was missing for me in reading this was maybe I just didn't get this dense propagator thing. Propagator or the dense propagator. I don't understand what we do once we have the where do we stick the symmetry information?
So we're going to eventually need a lookup table that says if I have one of these and one of these, can they go next to each other?
Mm-hmm.
So maybe we should try to write that data structure and
Sure.
then start trying to populate it.
Great. So this is the class neighbor oracle.
Yeah. But I think so one thing we don't have right now is right now our representation of a tile is just the name of the tile, but we also need to have the tile plus its orientation as a like data type. Oh, that looks great. Wall and floor. Thank you, Copilot, for this random code that makes no sense.
That isn't right, but it'll be it's an excellent start.
So we need like a class that's like an oriented tile, right? Which contains the name of the tile and the orientation, right?
Okay.
And what is orientation? That's like an enumerated type. That's like normal, clockwise. We need to figure out like what their order is.
Yeah, it could be like rotated 0, rotated 90.
Yeah.
And that could be reflected.
Yep.
I don't know where it goes, but like something like that.
Yes, exactly.
And I can't spell rotated, but thankfully Copilot can.
Keep going. Right, there's two more, right?
Well, is it like, what is it? Oh, it's reflected like along the 90. Like I didn't.
Oh, no, you just like reflect it right at the beginning, and then you rotate it through all the different rotations.
Oh.
Like I think an interesting thing we could just build right now is just a renderer that can render an oriented tile. Right now, our renderer can only render a normal tile.
Okay, cool. Yeah, this seems very, very reasonable.
Okay. So where's the renderer?
I see. So this is our tile store, our tile map. But we want our tile map to actually contain oriented tiles.
Right. So what is int? What is this I? Oh, the tiles are numbered, not named. That's fine. So this is the int. This is the ID.
Great. Okay.
So we want this to be a list of oriented tiles.
Oh, that's right. We wanted our grid again.
Where's tile map? Okay, so now we got to make it all work. Okay.
Oriented tile. We don't want to fill with 0.
Right. We'll take 0 and we'll take orientation rotated 0.
Okay. I kind of want to put this here.
Okay, same thing here. Next, and then we need like a random orientation. Values.
Sure. Get next int or whatever. It's like random.next int. Yeah, there you go.
And then values.length.
Yep.
Great.
What's it sad about? List int. Yep. Because this needs to be
oriented tile.
Yep. This.
Okay. And then get tile index now returns an oriented tile. Great.
Okay, and now we got to make this thing draw. Get tile by index. Okay, get tile. So this is going to be now.
Yep. Yep. And now we need to like apply a rotation to the canvas. Like we need to put a transform in the canvas before we draw this somehow.
Yeah. Well, so we just do canvas.save and canvas.restore. And we do apply transform. I don't know what the rect is there. Copilot right, and I just don't anticipate the need.
Yes, but we'll get there.
Wait, how are you and Copilot both?
Because I've made this bug so many times, I'm familiar with it. So what's going to happen is.
And what did Copilot just write out for me here? No, this is not correct.
What did you do?
I don't know. I
So
hit
you,
tab.
no,
I'm innocent until proven guilty.
you wrote all of this? This is bad. What?
Yeah, oh, it's totally non sequitur code here.
I mean,
okay. It needs.
Sure. Go home, Copilot. You're drunk. I'm going to delete this code.
Oh yeah, we're quite drunk here, and I'm not even drinking. Oriental tile. No. I wanted orientation, right?
Just the orientation, yeah. So here's the thing. So you right now, the way this is set up, the origin of the canvas is somewhere, and we're drawing the tile like way over here. So I think what we're going to want to do is translate the canvas so that the tile is centered on 0, 0, which will make it much easier to rotate and flip.
Yeah, I don't know when those rotation bugs. Like I'm familiar with the bug you're referring to. Of you don't want to rotate the whole canvas while you're already translated somewhere away from 0, 0. But sometimes those apply and sometimes those don't. Right? Sometimes those are problems and sometimes those don't, depending on how the drawing is implemented.
That's true. I think it will be, well, we can try to write this function. So let's just try to write this function. Switch on the orientation.
It's actually not, yeah, switching on the orientation is fine.
I was hoping Copilot would. The light bulb can fill it all in. Add missing clauses. Boom.
We don't actually type code anymore.
It's either light bulb or Copilot that does it for us.
We've moved to be low code engineers.
Okay, canvas.
Can we this? If we fall through, yeah, we're fine. Whatever. Whoa, sorry, I just started deleting your text. Go ahead. Okay.
Looks legit.
Pi over 2. Yeah, okay. This is gonna be pi.
Right.
Is Copilot doing it?
I mean, it can figure these things out. What is it? This is 3 pi over 2. Minus pi over 2. Same difference. Okay, reflect.
Yeah, minus pi over 2 would work too. Maybe that's what we should do actually. Okay. And then here we just reflect first.
X. Oh, we'll to see like which reflections they're interested in, but that's fine. We're reflecting in X, so like that. Just seems logical to me.
Oh, I see. You're saying that it might be a different.
It could be reflected in Y, right? There's a lot of conventions here that aren't really documented in the. We try to like discern it from the C# code. Was what is B?
Well, B is.
X.
All right, let's look at, say, like the T. This is unidirectional symmetry. So,
I don't know.
There's so much magic.
Like the person who wrote this clearly had it in mind, right? And you just wish that they would just like write some English somewhere that would like explain you what idea they had in their brain. I'm sure if I spoke. Oh, F. Symmetry equals F.
What?
So I think F means it has none of the symmetries. Like all 8 are distinct.
What? Okay. If we're less than 4, because less than 4 means like there was the magic here, right? There was this magic here where like less than 4. Yeah, here.
Yeah, those are rotations. So they're doing the reflect afterwards. It's interesting because they first do the rotates, and then they go back and reflect because they do a read back in the same array that they're populating. So let's put the reflect after the rotates, just for who knows,
for giggles.
Giggles. Okay. Anyway, let's try to draw it. We'll keep discerning. So I think we need to do here a transform. So here, if you go back to line
What's
2.
this possibility? Oh, this is, we hadn't done this part. Can we go back to what?
Oh, I don't think you want to uncomment that. That's gonna, yeah. If you go to line 224.
224. 224.
So I think we want to do this. Canvas dot translate this amount. And I never know whether it's minus this amount or positive this amount. And then these can be 0 now.
I worry you're solving a thing that we don't know is a problem yet.
I mean, sure. You want to see it?
Yeah.
I'm pretty confident it's a problem, but we can test it.
Well, just like, because the draw image rect might handle this case for us. Okay, I hear you that if we rotate the canvas first before we then tell it to draw at a specific thing, it's going to draw in the rotated coordinate space.
Yeah. We need like plus 1.5, right? X plus 0.5. Plus.
Because you're trying to put the rotation in the center.
Yeah, and then after we do this, we need to untranslate by this 0.5 times this. Something like that.
Okay.
Mad.
I think you probably want negative first, don't you? To go back? Well, I don't know. Let's just,
yeah,
I would honestly just try it.
2 positional, but found 1.
What happened here?
Oh, I have 2 parentheses? Okay. Let's try this and see what this draws like. This may not draw correctly. Huh.
I have no idea what we're seeing. Random but possibly rotated tiles?
I mean, if you look at this thing that looks like it has arms, like we're seeing it in a bunch of different rotations.
Are there any that we're seeing? Like, is this thing?
Yeah, look, T. There's
Which
T
ones
over
are
there. We're seeing a bunch of different ones in different rotations. It seems legit.
Okay. All right. Let's pretend it works. Keep moving.
Let's pretend it works. Okay, so now we need to do our oracle.
Okay. Well, don't we need like the data structure that we're solving in? Like, that's the thing that's missing in my mind, is that the like possibility space. Right? The data structure is some sort of like bit mask, I assume, of the n potential tiles, where n is actually relatively large. It's the total number of tiles and total number of symmetries.
Okay, so that we have that roughly around line 30. We can work from there if you want to work from there.
I think that's where we got to at the end of last show, and we kind of stopped.
Right, so possible tiles here. So possibilities, we have it times tile count, but we also need to be times orientation length, right? Those are really all the possibilities.
That's more than the number of possibilities, but yeah. Right. I suspect that this cardinality may be part of that. Like, the different tiles can have different cardinalities.
Well, it's just saying that this is like redundant, right? Because like imagine the all green tile, right?
Sure.
We're gonna think there's 8 of them when there's only 1 of them. But that's okay. Like, that's not such a big deal.
Okay.
So now we need to like select a possible tile. All right. So like we need to resolve.
We'd have to go look at the algorithm again, which is documented. All right. So the algorithm is written out here. Oh, but I remember it's written in like physics. Read the input. Oh, this is the tiled one. Do we have the tiled algorithm?
It's fine. We can just keep working through it. Like,
okay.
So I'm back in this wave class that we have.
Create an array with dimensions of output called wave in the source. Each element of this array represents a state of an n by n region in the output.
Which is the tile, yep.
A state of the n by n region is a superposition of the n patterns of the input with Boolean coefficients. Yeah? So like a bit mask, an n length bit mask.
Yep.
So state of pixel in the output is a superposition of the input colors with real coefficients.
Sure.
Okay.
Fancy physics talk, but fine.
False coefficient means that the corresponding pattern is forbidden. Yes.
Right. So this is just what we have, right? So we have this possibilities class, which is a bit vector.
Yep.
And so like if we try to like look, let's observe at position X and Y, we just need to pick one of the possibilities. So our possibilities are close. This is, it's
really,
it's
I feel like we need to add
nonsense.
like a third like icon on the screen, which is like Copilot.
Copilot is the rubber duck has come to life in the form.
The
of
rubber
Copilot.
duck has come to life.
Okay, but this is fine. So possibilities. Now we need to select a random one. So we need to know like how many of your bits are actually like. We have this list of a random. If you scroll up slightly, so you can see line 20.
Mm-hmm.
We have a list of possible bools. We need to pick a random one. We need like an int.
Like sample or something?
Yeah,
okay.
Sample. Get count is pretty good. Okay.
And
int.
does the sample select a true one? Or just any one?
It's also a random one, right? Get random. There you go. Except it's pretty close. Okay, give me an index for this. Okay. And then while the storage index, that doesn't make a lot of sense, but so now I need to pick a random. So this tells me which one I want. So now I need to go iterate through this. For int I equals 0, I is less than storage. If storage I, that doesn't make any sense. Well, this is less than thing. Now, what am I trying to do here?
I don't know. You're trying to like filter eyes where they're true and then select a random one from that?
Correct. That would be an easier way of doing it. Sure. I like your way. Your way of
so you just do okay, you're on it.
Filter is not really what I want. I want to
var true indices.
Yep. That's just going to give you a bunch of trues. We need the indexes.
Yeah. Does Dart have an enumerate? I don't think it does.
Enumerate?
Dart enumerate list.
That's fine. We could just use closures, right? We could say int index
equals as map. Today I learned. Yeah, you just do it this way with a for loop. For int I.
Oh, okay.
To are true in the C's.
Sure.
If storage I, and we do true indices that add.
Okay.
A break. Okay. And then
let me do true indices. Accept this.
Did it. Copilot did it.
Oh, good job, Copilot. Yep, like that.
Copilot, go.
Okay, I feel like there's a better way of doing this, but this is fun.
Well, there's also a better way than having a variable length list of rules, but we're living on the edge here. Okay, it cannot be this orientation.
Good morning to you as well. 5 a.m. Wow. Well, welcome to the show. Bright and early. Hopefully you're drinking your coffee or other morning beverage.
Yeah, 5 a.m. That's even earlier than I get up. Okay. Possibly index where? What are we doing here? Observe.
All right, so this is fine. So we take our, this is our like observation is this thing dot get random.
Okay.
Okay. So now we need to I think we need to remember our tile count somewhere. Because like the first,
he says we clearly need a better enumerator list than ASMAP. I'm sure there's a package that does it, but I agree.
Hi, Eric's here too. You know, hi.
It's okay. I don't feel forgotten.
We need to remember our tile count. Tile count.
Just wait. People will start saying hi to Copilot and just Copilot.
And soon the show will just be Copilot. We're running the whole show. We'll be at the beach and Copilot will write all of our code. It'll be amazing. Okay. So, right. So the orientation we want is, our orientation is now observation integer slash our tile count. And our final tile index tile ID is like our observation on the tile count.
Okay, help me understand. What are we doing here? So, possible tiles. This is all of the.
I think we made our lives unnecessarily difficult.
Why? What did we do?
So
here?
we packed all of our tiles and our orientations into one indices. But I think it would be better if we just did this. There's a list of
if we have a third dimension to our array here.
Well, what if we just put an oriented tile as our possibility, right? Like, what if this was a map from oriented tile to bool?
Sure.
Possible tiles, right? And then if we ruled out a tile, that we would just set the tile to false.
Mm-hmm. Do we need to make this thing? We probably have to like do the hash thing.
The hash thing.
Yeah, there we go. This.
Oh, okay. Yep. Yep.
Good job, Copilot.
Well, it's not quite good. I don't like its hash function that it generates, actually.
Oh, because it really should be object dot.
Yeah. Object
hash.
Yep.
ID and orientation.
Yeah.
Is identical. Or was this identical?
Identical is fine.
Or other is Oriental. What? Oh, I see. Either this is the same thing, or the other isn't Oriental. Our runtime types match.
The equality generates is I think reasonable.
I see. This could be because this could be a subclass of Oriental. That's why we want to check our runtime types.
Correct.
Okay. All right. Like we should not have to write this.
Yeah, you write the same code all the time. It seems like the compiler could help you out with that.
But we'll get there.
Yeah. Oh, they said hi to you too.
Oh, why thank you.
So I'm still working on those possibilities.
I think this is a totally fun approach.
I'm trying to figure out how to initialize it, though. Should we initialize it to empty? Like, what is... Like, it's...
You need to be able to, for a tile, ask for all of its oriented tiles.
well, I think we could just make a loop here. Right? We can say for int the tile count, possible tiles. And we can say for final orientation. I feel like we're not being very efficient here. Like we're for a thing that really could just be like a bit mask, or but that's maybe that's an optimization step that comes later.
Yep. Root of all evil and all that.
Possible tiles, oriented tile, true. Okay. Possible tiles.
So this is going to create oriented tiles that are not actually specified as possible.
But they're all possible, right? Just some of them are redundant.
I see.
They're like this one rotated 90 degrees is the same as the other one rotated 180 degrees or something.
I hear you. All right. Possible
So
tiles.
now we need to redo our get random function.
This is late.
The maps have lengths? They do.
Now get random should just but it's gonna, is it gonna sample correctly? It's gonna bias towards.
Well, we could do this. We can remove it. Just remove tile, right? This is really a set. It's not really a map. Okay, it's just like a set of oriented tiles, which is our possible tiles. It's starting to make more sense.
Okay.
Possible tiles. Add. This is how you like. I'm a big fan of like understanding your problem through refactoring. Like you write code that makes not very much sense, and you like make it make more and more sense, and you discover, aha, it's really a set, which should have been obvious at the beginning since it's a set of possibilities. But sometimes you have to approach it indirectly.
And so now we just do
just possible tiles.
Yep. Possible tiles.
I mean, the easiest thing would just be to convert to a list, right? Final list is possible tiles, list, bang, and then sample like that. List of possible tiles. Okay, that looks legit.
Okay. I think
So now I don't do
as
this.
list, and that would have been okay. You could have saved yourself a few characters there.
Okay, great. So now what we observe is much easier. Get random just returns. But this is not quite true. This is like final actual tile equals this. Now we need to do rule out impossible neighbors.
Yep.
We can come back to that.
Well, so my understanding is the very first step of the algorithm, we'd have to go look, is that you collapse one of the waves or whatever, and then you collapse around it.
This is the part that we need to do now.
Okay.
Or well, maybe not. So okay. So now what do you want to do? So suppose
what is this going to display? Anything? Oh, I guess we're not even using this.
We're not using it yet. But like, let's assume that we had the orientation oracle, or the what would you call it? The
neighbor oracle, I think.
Yeah. Let's try to write this function, assuming we had the neighbor oracle.
Yeah. You know me. I'm a big fan of fantasy code.
So how should we do that? Do you want to do that, or should I do it?
Well, so I think this is like, it's a loop. The way this algorithm works is it's a loop. So I'm not sure that like this one observe makes any sense.
Okay.
It's like you like
collapse the wave function.
Yeah, exactly. Void collapse. What's our output?
Our output should be a tile map.
All right, so
the tile map says
tile map.
Yep.
So this is the while. Okay, let me spit this out so I don't forget it. While first thing we do is we pick an actual tile for one thing. So pick random tile and collapse.
Okay.
It, right? Then while we still have tiles to collapse, do the same.
Well, let's not do the same, right? We need to pick, like we pick a maximally.
Oh, is that what it does? Maximally? Oh yeah, maximally constrained. Yeah.
Okay.
It lets you find. Wow, Copilot is like updating its suggestions as you go.
Yeah, I've used it to write documentation. It's actually quite reasonable documentation. And when it writes incorrect documentation, that either means your code is wrong and doesn't do the obvious thing, or you really should document the thing that it got wrong.
I actually find it very distracting when I'm trying to write English because it does not share my voice.
Oh, I see.
And so I wish it had a feature to turn it off for certain types of files because I want to turn it off for Markdown, but leave it on for other things. I think actually it does do that. You just have to press the right button. Anyways. Repeat until we have no more tiles to collapse. If the location has no possibilities, give up. Go back to start.
Oh, but we just say, yeah. Let's just throw an exception or something. Give up. Yeah.
Like we could have something like we try 3 times or something like that. But
and collapse it has this thing where we rule out possibilities.
All right, so we need to pick a random. That's not right though.
That's not right though.
All right, so we need what does tile map start with?
Well, we need to go through all of the. So let's write a function called. So like picks a random thing, right? So it's awkward because it needs to return an x and a y.
I'm sorry. This is wrong. What do we? Oh, so possible tiles is our.
You just put this getter on here if you want. Oh, no, now you just have a width and height getter.
Yep.
Okay.
Right.
Yep.
I really don't like this. You always want to just have a random. Reason why is that sometimes you want to control the random. So you don't want to just like be making a new random all the time. You want to just do store a random and use it.
All right, I'm just going to initialize it for now. Okay.
So this is our random location, right? So, and now we want to. Okay, so we got an actual tile. This needs to be.
We don't need to do anything with this. This is fine.
But should it be this or something?
No, we could just do that at the very end. Here, when we get random, we should just rule out all the other possibilities. So we should say final actual is this.
Oh.
And we'll say possible tiles.
It's like all but.
We'll just clear it out. Clear, and then we'll say possible tiles add actual. And then we'll return.
Get random?
What's that? We'll just say resolve.
I see.
And then we'll have a getter that's like, pool is resolved, which is just that possible tiles length is 1.
Mm-hmm.
Right?
Specifically 1. and then we'll get is or something like that, or like
is impossible.
Yeah, it's impossible. Yep.
Yep.
Yep. I'm not sure I like this design.
Okay. Tell
I
me
would
more.
probably do void resolve 2. Yeah,
that's
which
fine.
does that. But the other thing that this does would be it could like
assert.
Correct.
Okay. Assert that possible tiles contains tile.
I like that assert is where my mind is going, because the other one would have like picked a maybe I don't know, maybe I'm misremembering.
So you're gonna put the random choice down there.
I see. I deleted your fancy random.
It's fine. We should put it in the other algorithm anyway. Like that should be the one that picks the random one, and then it tells the possibilities to resolve. Yeah. And you also want to get around here that's like resolve tile.
Copilot. Why is this math.random? Do we need this to be math? Can we just?
No, you can just pass in a random.
Can we remove the prefix from math?
Oh, sure.
And this is random.
So that you separated the side effect from the non-side effect.
Yes. I made the side effects. It's no longer a side effect. It's an effect. It is explicit.
Great.
And I was so confident we would have this done in 20 minutes.
No, that's okay. We're doing good. Okay, so get the random. Then we need to take this thing. We need to resolve it to resolve to actual tile.
Mm-hmm.
And now we need to go like propagate to the neighbors. Okay.
Yeah, it's like constrain neighbors or something.
Yeah, constrain neighbors. So how are we going to do that? We need to go like
it's really on us, right? It's like
it's like a search, right? It's like a BFS, like a breadth first search. As long as we keep making changes, you need to keep going, keep exploring through the network to keep adding more and more constraints.
It's actually like a bool.
Like, did you actually change anything?
Or I was thinking, like, is it still possible? I don't know. We leave void for now. It's always returning a bool is always a little magic numbery. It's like, what does the bool mean?
Constrain neighbors. You're gonna pass in like the X and Y.
Yep. Okay. And then
it's basically just this in a loop, right? As long as we change this selection to be better.
It's like you want like, so we really want a position class, but so if you do like var position is equal to position, I can't spell to save my life, equals most constrained.
Mm-hmm.
We do
right. It's just this whole loop, right? You do exactly this.
Oh yeah, we pick a random. Oh yeah.
And this is just the same thing, right? It just at the beginning they're all maximally unconstrained. So the most constrained is just a random one.
All right, so this is var target.
I didn't know Flutter was used for game dev. Yeah, this is I think an emerging thing. Like Flutter is obviously more popular for making apps, which is the original design intent, but it's got a powerful graphics engine. People using it to make games, and we've had a lot of fun on the show using it to make games.
So I think we have this while, probably not while true, but we'll say it is for the moment.
Well, it's really while target bang equals null, right?
then, oh, okay. So if target, but
this is really good at. Okay. Right.
Like if get at target dot is empty or whatever, or is impossible.
What is this?
No, we'll do row. Yeah.
Neighbors target. So I'll write get at if you like.
Do we write enough checks?
Yeah, we can.
And then now we have to take this fully
this,
constrained thing.
We're gonna make this location class for the billionth time.
What's that?
I'm making the location class for the billionth time. Really like things that are missing from your library.
Yeah, I think that there are some like there's like a geometry package that's missing from the Dart ecosystem. Okay, because we keep writing it.
Keep writing it.
This is not from. It's just like slightly better. It's like var tiles. Right, and then it's going to be it's going to be return tile map, possible tiles dot a map, and it's like row dot map. P be like P dot resolved tile. What I do? Is that at all possible? I don't think that's quite right. All right. Constrain neighbor location, get maximally constrained position. Okay. Yep.
This is mad. I need like a to list, I think.
Yeah. There's like need like two to lists. You need the inner one and the outer one.
Right.
The inner one needs to be that to list. Oops. To list. And the outer one that to list. Okay, that works. I actually don't know if they're rows. Did you do the Y first?
Tile map.
Yeah, so they're rows.
Oh, it's from tiles is what you want. Okay, it's just different. Yeah.
That's a service for.
So now we have a few more checks we need to clear here. So we're also at time, but we're getting there.
Tile map random. Okay, yeah, I know. We should stop. I'm just, I'm writing checks. So just removing these math.py. Math.py. I'm almost done. I promise I'm coming to bed, Mom.
Just one more game.
Just one more game. Just one more line of code.
One more line of code.
Okay, we calling it?
We're calling it. We're making progress.
So are we, despite my expectations that we would be done and need extra content for tonight, are we going to go to a third round?
I think so. We have the structure in place, right? We have a couple of those functions we need to fill out, and then we're going to have to construct the Oracle from the XML file, which we spent a lot of time at the beginning of the episode concerned about that, which we will maybe sort out in the Easy Bake Oven.
Yeah, we didn't do anything in the Easy Bake Oven this week, and that would have helped because there is a bunch of just like reading the C# code to figure out what it's trying to do, or reading one of the 10 translations. Like I remember looking at that library, and it's been ported to everything under the sun. I'm sure someone
has the no magic numbers aesthetic, and
Yeah,
we'll write code the way that we like.
Yeah. So we could just read we could read the Swift version or whatever and see what it's like. So, any news from Pizza Town? We're kind of over time, so maybe it's
Pizza Town. Hands Pizza with my parents. They make 1.5 dough recipes per pizza, so instead the pizzas are bigger, and so I had a lot of fun throwing them up in the air because they were huge.
I went to my GP, my whatever PCP or whatever for the first time since the pandemic, and asked them, how one should eat, and they told me I should be eating half vegetables.
So like a pizza with half vegetables, half pepperoni.
No, I think like half of the thing would just be broccoli, and then maybe the rest could be pizza. It was like I was supposed to be eating half vegetables, a quarter lean protein, and a quarter carbs. That was news to me. I did not eat half vegetables. I'm going to need some significant dietary adjustments.
That's a really stacked pizza. If you want half of your pizza to be vegetables, it's going to be really, really thick layer of vegetables.
Anyways, this was fun as always. Maybe we'll do more in the Easy Bake Oven this week so we can be sure to collapse the wave next time.
Sounds great. See you all next week.
Take care.